Hi everyone, in today's tutorial we want to evaluate the following limits. Limit as x approaches 16 of 4 minus root x all over 16x minus x squared. We want to evaluate this limit. 4 minus root x all over 16 minus x squared is a rational function. We want to evaluate this rational limit. So let us first of all check to see if we can just go ahead and apply the quotient limit theorem. With the quotient limit theorem, it demands that we check the limit at the limit point. Let us see. When we put x equals to 16 there, what do we get? We have limit as x approaches 16 of 4 minus root 16 all over 16 into 16 minus 16 squared. This gives us limit as x approaches 16 of 4 minus root 16 is 4 all over 16 squared minus 16 squared. Now this finally gives us 0 over 0, and 0 over 0 is indeterminate. So we don't have any conclusion to make at this point. So with the quotient limit theorem, we get nowhere. We can't get any value for this limit. So we are forced to evaluate this limit now using either algebraic simplification or applying the L'Hopital's rule, since we have indeterminate 0 over 0. Now, choosing the algebraic simplification, we see that the denominator, this denominator, 16x minus x squared, can be factorized. Since x is common, can be factorized into x into 16 minus x. That's what we see at the denominator. And we also know that 16 minus x is actually a difference of 2 squares. Let's write it out. 16 is 4 squared, and the x is the same as root x, all of that squared. So 16 minus x is actually a difference of 2 squares. If we apply the difference of squares identities, we will now write this out as 4 minus root x into 4 plus root x when we apply the difference of squares identities. Now let's take this therefore and put here. Now our limit therefore becomes limit as x approaches 16 of 4 minus root x all over x into, we are writing this out, x into, in the place of 16 minus x, we're going to write out this 4 minus root x into 4 plus root x. So this is what we get for our limit. Okay, now we see 4 minus root x at the numerator. This cancels out with 4 minus root x down here. So our limit becomes limit as x approaches 16 of 1 all over x into 4 plus root x. All right, now let's apply our limit point 16 and see what we get. So we're going to have limit as x, limit, yes, we're going to have limit as x approaches 16 of 1 all over 16 into 4 plus root 16. All right, that's simply going to give us 1 all over 16 into 4 plus root 16 is 4. Okay, which is going to give us 1 all over 16 times 8. Okay, this gives us the value of our limit. Now let's take the second limit. Let's take the second exercise. We are given the exercise to find the limit as x approaches 7 of root x plus 2 minus 3 all over x minus 7. This again is a rational function, and at the limit point 7, we have indeterminate 0 over 0. Let's demonstrate that. Okay, at the limit point 7, we have root of 7 plus 2 minus 3 all over 7 minus 7. This gives us root of 9 minus 3 all over 7 minus 7. Root of 9 is 3, so we have 3 minus 3 all over 7 minus 7, which gives us 0 over 0, which is indeterminate. So in this other case, we are not going to be able to apply the quotient limit theorem. So we have to resort to algebraic simplification or using the L'Hopital's rule. Now, with the algebraic simplification, we know that root x plus 2 minus 3 actually comes from, we actually see that as the part of the difference of two squares, which is from the difference of squares where we have root x plus 2 squared minus 3 squared. Let's develop this difference of squares here that we have. When we develop the difference of squares, we're going to have root x plus 2 root x plus 2 minus 3 into root x plus 2 plus 3. Okay, so how do we now get this from that difference of squares? We see our root x plus 2 minus 3, our root x plus 2 minus 3, here it is. All right, so we're actually saying that this one, root x plus 2 squared minus 3 is equal to, minus 3 squared is equal to that. Okay, so from there, we'll get our root x plus 2 minus 3, this is it here, as root x plus 2 minus 3 to be equal to root x plus 2 squared minus 3 squared, all of that divided by root x plus 2 plus 3. All right, this expression at the numerator, this expression can be replaced with this other expression, but this is the same as the square cancel square root. We have x plus 2, and then 3 squared is 9 all over root x plus 2 plus 3. So this gives us x, 2 minus 9 is negative 7 all over root x plus 2 plus 3. So we're going to replace root x plus 2 minus 3 by this expression here. So our limit now becomes, limit as x approaches 7 of x minus 7 all over root x plus 2 plus 3, all of that divided by x minus 7. Now, when we look at it strictly, we'll see that x minus 7 will cancel out x minus 7. And so our limit becomes, limit as x approaches 7 of 1 all over root x plus 2 plus 3. Now let's place 7 there and see what we get. We have 1 all over root 7 plus 2 plus 3, which is 1 all over root 9 plus 3, which is simply 1 all over 3 plus 3, which gives us which gives us 1 all over 6. So our limit is 1 all over 6.